National National Institute of Technology, Arunachal Pradesh. He received the PhD degree in Computer Science and Engineering from the Jawaharlal Nehru University, New Delhi, India. His research interests include support vector machines, ELM, RVFL, KRR, and other machine learning techniques. He has published over 55 plus referred journals and conference papers internationally. Next, Dr. Vijay Bhaskar Samwal is currently working as an assistant professor at Department of Computer Science and Engineering, National Institute of Technology, Bhopal. Before joining NIT Bhopal, he was working at NIT Rourkela. He has earned his doctorate degree in robotics from IIIT Allahabad in the year 2017, MTech in Information Technology from IIIT Allahabad 2010, and BTech in IT from College of Engineering, Roorkee 2008. His areas of research are bipedal robotics, gait analysis and synthesis, artificial intelligence, machine learning, and theoretical computer science. He has published more than 25 SCI research papers. It's my pleasure to welcome you all over here, respected dignitaries. Uh, a gentle reminder to all of you, please consider the evaluation sheets that is being shared with you all through mail to evaluate all the presenters so that we could conduct overall all evaluation for the best paper awards. Now it's all over to you. We can start with the first presentation. So first presenter is Miss Karuturi Deepti. Is she present? Hello, Deepti, Miss Deepti. Uh, Deepti, I can see you as a participant, but you are not audible if you are trying to. Okay. Uh, with the permission of session chair, can we go for the next presentation? Whenever she is available, we can start her presentation. Dr. Vijay, Dr.
Yeah, please, you continue with the second.
Yeah. Next presenter, Mrs. Vijay Lakshmi.
Yeah, this is Vijay Lakshmi. I'm available.
Okay. Can you please share your screen and start the presentation?
Yes.
Okay. Over to you.
Excuse me, ma'am. I'm not able to share my screen.
Okay, I'm. Now you try.
Yeah, I'm able to.
Madam, also you switch on your camera for some time because we are recording. So
Yeah,
for
yes,
some
sir.
time, for a couple of minutes, you can switch on so that after that, if network is not sufficient, then you may switch off.
Okay.
Yeah, please.
Now, is my screen visible?
No, ma'am. Actually, your video is there, but screen. Yeah, it is present.
Ma'am, I think I'll turn off my video.
No, it's okay. Okay, madam. Now it's okay. Now you are
It's okay.
visible. Yeah.
Okay.
Right.
Can I start my presentation?
Yes, please. Can you make it full screen?
Yeah, it's full screen now.
Okay, fine. You continue.
Yes.
So, good afternoon, everyone.
Uh,
I'm Vijay Lakshmi, and I'm from BMS Institute of Technology and Management, Bengaluru. I'm here to present on our work, performance analysis of parametric and non-parametric classifier models for predicting the liver disease. So here my main aim is to analyze the performance of parametric classifiers and non-parametric classifier using some quantitative measures. And we have selected to work on liver disease because liver is a very important organ of the body. And it plays a very important role in various functionalities. So it is very important to monitor the health of liver. So it gets affected by various parameters. So I thought it will be good if you monitor the health of the liver. Traditionally, based on the symptoms, if the liver get afflicted by other parameters, traditionally like health experts, they just monitor the symptoms and they diagnose the device, and they refer the patient for any treatment. So here we are trying to bring up introduce machine learning models where we can predict based on certain key characteristics, like there is the presence of the liver disease or not. Like here we have included, like we have not considered here a particular liver disease. We are just taking the key parameters and we are trying to find out based on the key parameters whether there is presence of the disease or not. Okay. So here, like when I say about the key characteristics, you can find the key characteristics using different biomarkers. Like you can consider imaging techniques like CT scans or ultrasound or MRI, or you can analyze the blood. You can conduct various tests on the blood samples, and you can measure the level of proteins or enzymes, and based on those level you can identify the presence of the presence of the disease. So we went for the observations, observations from various analysis of the blood samples, and those observations we have taken as the key parameters, and using those key parameters will be given to the machine learning models for training, and based on that we'll be dividing the new sample into whether it is afflicted by disease or not. So when
your PPT is not moving.
It's not moving, sir. Okay.
No.
Now?
It is also not visible full screen, maybe.
Okay.
You see your entire screen, maybe then we'll get.
Yeah, I've shown the entire screen.
Okay.
Now
it is showing problem description now. Yeah.
Yeah. So here we are, as I told you, like we are going for the observations what we get from the various blood samples, and that will be given to the machine learning models to understand the relationship between the features and the labels, and based on that the decision is made whether the sample is afflicted or it's healthy. And coming to we have gone through various papers on the previous papers to identify how the work is being carried out. We could find out that many researchers have worked on this using both imaging techniques and also on the blood analysis. And most of the works are being quantitatively analyzed, and accuracy is measured, and also area under the curve and many other parameters are measured. But here, along with the accuracy, we thought we would we will also find out the errors during measurement, because it is healthcare. Along with accuracy, if you also measure what is the error, because if the sample is if the positive sample is classified as negative or the negative sample is classified as the positive, it may lead to like tensions, and if the person is healthy, he may be directed towards the treatment. So all these things you can reduce, like if you design the model and analyze using those errors. And also we thought of statistically analyzing the created models to find out what is the association between the actual class label and also the predicted class label. So we have considered the machine learning models, and we performed like analysis using all these metrics using confusion matrix. So we framed confusion matrix, and from the confusion matrix, we plotted all these parameters which are listed here, like accuracy, sensitivity, selectivity, false positive rate, false negative rate, then Matthews correlation coefficient, chi-square value, kappa value, all that. Okay, this is our methodology. We collected the data samples from UCI machine learning repository. From there, we got 583 samples. So out of that, 416 samples were like labeled with the disease, and 116 samples were labeled with non-disease. Okay, so we took these samples and we just divided them into two sets using a whole dot approach. One is for training and other one is for testing. And
Vijay Lakshmi, again your slide is not moving. It is not also in full mode. As you convert in PPT, then we'll be able to see.
This is PPT, sir.
But sorry, PDF you can convert, then we can see. Because,
so you want me to convert and then
because this is not full screen also visible.
Okay.
Can you press because not to convert, because we are unable to see what you are. Now it is showing methodology, but it is not full screen. Control F5, can you press?
Yes, yes, yes.
Now it is reduced. Control F5 was there.
Yeah, control. Oh,
but it is reduced your screen.
I'll go to full screen.
Now we are able to see.
I think when I just escape and do it, you are able to see, sir.
Yeah.
Okay, I was talking about the methodology. So we are dividing the data set into liver disease data set. So already we have the.
Now we are at the result and discussion section. Can you go to slideshow, and from there can you select full screen?
Yeah, it is in the slideshow mode and full screen. I don't know what is the. So is the slides, are the slides moving?
No, they are not moving in
no.
The result and discussion section.
Okay. So I'll just escape and now.
Now it is moving.
Sir, I don't know actually what is happening. Like when I go to full screen, the slide is
okay.
remaining.
So wherever you are reaching on particular slide, you tell the slide number also, so that we can understand your slide is moving.
Okay.
And majorly you focus on your result discussion because you have, I think, another 5 minutes to finish.
Okay, sir. Okay.
And you explain your major contribution and compare
sir,
with the
major.
state of art.
Okay. So I'll just quickly methodology, like when we actually got this data set, we could find that we had two categories of the data, healthy data and the disease infected data. And we found that the data set is skewed data set, I'm sorry. So one category of the samples were 79% and the other category were 29%. So what we did is we applied oversampling so that the ratio of the data becomes 1:1. That is the first thing we did. And the major contribution is, along with the accuracy, we were more interested in identifying the errors because we had to stop misclassification. So we considered various parameters. These are the performance metrics what we considered after framing the confusion matrix, after training all those parametric and non-parametric models. This is statistical analysis. And these
your
are
slides are not moving. Your slides are not moving.
Madam, first you maximize your window, top right, you click on maximize.
Yeah, it's, yes, sir, it's maximized.
Okay.
It's maximized. Now I'm going for slideshow.
Yeah, now slideshow.
Yes. So coming to the, sir, shall I go to the result section? So we considered various parameters. So the parameters were computed, and just when we compared these parameters like sensitivity, specificity, precision, positive, false positive rate, negative rate, accuracy, F1 score, MCC, Matthews correlation coefficient, we could find that SVM classifier with the radial basis function was performing better, and this is a non-parametric method. So this is what the this is where we came to the conclusion that when we compared the performance of parametric classifiers and non-parametric classifiers using various quantitative measures, we observed that SVM was performing better, and it has a very good class discrimination ability. Like it was significant in differentiating the classes, unseen samples, into whether the sample is afflicted with the disease or not. And when you come to the false negative rate and false positive rate in this graph, you can see that SVM is very much less when compared to all other classifiers.
We are unable to see graph. Move on that slide 14.
Yes, sir.
You are in 14 number slide or which number?
It is 14 foot. Yeah.
So that's now it is.
Yes, sir.
Okay, move in next slide 15 and 16.
So this was the result what we get. So we could identify SVM was performing better, and our main intention was to identify the errors because if the negative sample is predicted as positive, like unnecessarily it will create tension among the person who has undergone the analysis. And if the positive sample is predicted as negative, then like he'll be missing the treatment what he actually requires. So SVM was good. So I think this model can assist various clinicians. They can take this as aid in classifying the data in a better way.
Okay.
Yes, sir.
Concluding slide.
Yeah, yes, sir.
Move on 15. Can you open 15 number slide 16 because we are unable to see, only we are seeing 14.
Okay.
Yeah. So I have few questions. I think that you have finished.
Yes.
Okay. So what was the ratio of these class imbalance as you told that you have excluded?
So one was 79% and other was 29%.
But it was not that much skewed. Then you have applied oversampling.
Yeah, I have applied oversampling.
Okay, still I'm looking for what is the novelty of your work?
Sir, novelty is like our side, we just tried to compare the performance. Novelty is like we didn't contribute. It was like we had to understand how the performance of parametric and non-parametric classifiers are like in their own way, how best they are on a certain
so which one is better? Which one is better?
I identified a non-parametric classifier are better.
Why?
In very good they provide very good discrimination among the classes.
Why? Any reason? Any?
Sir, because like as you train, though non-parametric classifiers they take more time for training, and they don't make any assumptions on the previous data. So they take the data and they train, and they can also like what do you say, sir? The number of parameters are not fixed. So based on the samples what we give for training, they can vary the number of parameters, and they can fit any of the functions. Like in case of parametric classifier, like they make the initial assumption and they stick on to the particular function, but here they can fit to any of the function.
Fine. To be stick very concise answer.
Yeah.
Two more questions I will ask. One more question is that related to this. You have not compared your work with any state of art work.
Sir,
okay, these are your finding.
Yes,
Okay.
sir.
Second thing, as you are telling parametrics, so as you will increase number of parameters.
Yeah.
Okay. So what output you are expecting if you increase and your whether model will get overfitted or underfitted? If you
it will get overfitted, sir, sometimes. That is one drawback of non-parametric.
So then how will you ensure the generality of your model, as well as are you considering the probabilistic based model also?
No, sir. Probabilistic model. I think further I can use some regularization.
Okay, that's fine. We have not,
parameter.
and why we have not compared with the state of art works?
Sir, actually, the works what I considered, like they had given either accuracy, AUC, and I didn't get like these statistical measures. I could have compared only accuracy, but I thought
fine.
if I get any
Fine.
works with all the parameters what I have considered, I think I would have made a comparison.
Okay, if data is skew, accuracy is correct measure or some other performance?
I think, sir, F1 measure is best performance to compare when the data is skewed.
Okay, fine. Thank you. I will ask to, I will hand over to other session experts. Maybe madam can ask. Yeah.
Yes.
Okay. Yeah.
So I have a couple of questions.
Yes.
First thing is, so you had a 80%, 79% and 29%, something like that contribution.
Yes. Yeah.
So what was the division of testing versus training data?
80:20.
80:20?
Yeah.
And how much oversampling did you perform?
Ma'am, the data set what I took was it was having 79% of one category and 29% of one category. So so the 29% I increased the size of that was increased to the majority class size. I made it 1:1. Then I applied the holdout method to divide the entire data set into training and testing.
No. When you do it like that, then the testing results are not accurate, because in that case, the model has already seen the data. First, you have to divide between testing and training, and then only you can do oversampling. In your flow chart, how it was written, and that is how it should be. Otherwise, your results are not correct. Your model does not have unseen test data. It has already seen the data because you have oversampled it before taking out the testing part. Okay. The other is when we are talking about healthcare, is sensitivity more important, a better sensitivity or a better selectivity? Can you go back to your slide number 12, I guess?
Okay.
Sensitivity or specificity, which of these two parameters is more important?
And both are important.
If both are equally important, then accuracy is good enough.
No, accuracy is like
you are reference to one of these parameters.
Yes.
And then what you are doing actually is you are again comparing models based on accuracy. The implication that you had in starting of your presentation was that we are not going to look at accuracy because it's not a good measure when it comes to skewed data.
Yeah.
But you are also using accuracy to compare the model. You should have chosen either sensitivity or specificity or to make that selection.
Yes.
Again, using accuracy, and if you are using accuracy, then why not compare with other methods which are using it?
Yeah. Like I think I failed in that. I think I'll make this correction.
Yes, there are these fundamental issues that must be answered. Okay, I also can't see any novelty in the work. Okay, that's it from my side.
Like, can I end this the presentation here.
Sankhe, can you guide her?
Yes, please. Yes, please. Yes, madam, you can. You
Yeah,
can
thank
leave.
you. Yeah, thank you
You
very
can.
much.
Yes, yes. You can off your sharing, screen
Yes,
sharing.
yes. Yeah.
Shanky, next paper you can call, please.
Yes, sir. Next for the first presenter, Miss Dipti is present. Is she available now?
Excuse me, ma'am. Yeah, Deepthi has some internet issues. I am the other team member. I joined. If it is okay, I'll present it.
No, you are the co-author or other team? Co-author?
Co-authors.
Okay, okay. Then you can. No issue. You can.
Yes.
But
Okay.
later you inform for changes. Otherwise, certificate will be issued on her name.
Okay. Okay. Okay, sir.
Because she has noted as the presenter, so that later you can inform and allow us to change, so that you will get the certificate, right? Yes.
Okay. Okay. Sure, sir.
Yes, please continue.
Yes, sir. I'm sharing my. Is my screen visible, sir?
Yeah, visible slideshow you can put, and switch on your camera for first 2 to 3 minutes. After that, you can put off. Otherwise, network may not be sufficient for you, right? You can.
Just a minute, sir.
Yeah. Just for 2 to 3 minutes, because we will record it. After that, you can switch off.
Yes, sir. Um,
Go ahead, please. Go ahead, please.
yes, sir. I'm trying to switch on the camera.
If it is a problem, then you can go ahead as it is.
Yes, sir.
Right, please.
So I'll go ahead, sir. I'll try switching on at the end if it is
No
okay.
issue. No issue. You can.
Yes. Yes, sir. Our paper is about the effective heart disease prediction using the hybrid ensemble machine learning models. And as we know, there is an incredible increase in the.
Put slideshow, madam. Put slideshow.
Yes, sir. Yes, sir. Yes, sir. As we know, there are increasing in the deaths due to heart diseases. Our paper deals with the heart disease prediction, which will predict earlier. So there will be a easy of diagnosis. So we know that the heart is a vital organ in the human body, and there are considerable number of deaths due to the heart disease. So there are many there are many factors such as age, gender. There are many factors which are adding on to this heart disease. This paper deals about the prediction of heart disease using the machine learning models. This is the literature survey. These are the papers, which we took for the reference for this paper. These are some of the papers we took for the literature survey, sir. And this is the problem description. The identification of significant features for the prediction of heart disease at early stage has become a key element. So the aim of this paper is considering the significant features by applying the machine learning techniques, which results in the improving the accuracy of cardiovascular diseases, sir. And this is our methodology. We took the UCI data repository, sir. Initially, we pre-processed the data, i.e. we did the data visualization, in which in which in order to know the number of attributes and the features we are dealing with, then we went on to the data cleaning. As you can see in the flow chart, in the data cleaning we removed the missing values and
ठीक है, मैं आई थिंक आ गया नेट मेरा, मैं ज्वाइन कर ले, नहीं मैं ज्वाइन कर लिया हूँ, वो आ गया, नेट आ गया। ठीक है, चाहिए।
should I continue, sir?
Yes, please continue, please.
Yeah, and then we went on to the data analysis in order to know the relations between the two features, how the one feature is affecting the output of the output. So this is what we done in the data pre-processing, and then we go to the feature selection. In feature selection, what we did is we took all the features. I mean, we consider all the features. Exactly, we not do any feature selection as we consider all the features. This is one of the plus point of the paper. We wanted to take all the features instead of taking the important features, and then we come to the classification using the we implemented all the classification algorithms, and we did the performance evaluation using many performance metrics. And then then the random forest and the logistic regression, we got more accuracy for random forest and logistic regression when we performed the evaluation. So we combined it in order to into an ensemble model, expecting it to give a more accuracy. We combined it using max voting classifier, sir, using soft voting. These are the results we obtained when we implemented, sir. As you can see in here, the logistic regression and the random forest got more accuracy. So we combined these both in order to form an ensemble model using max voting classifier, sir. We even combined the remaining all, like leaving the random forest and the logistic regression aside, we combined the remaining models in order to make an ensemble model, which gave an accuracy of 80.61. But this ensemble model of random forest and logistic regression gave more accuracy. These are the results. These are the results of the performance metrics, the precision, F1 score, sensitivity, and specificity. And this is the conclusion, sir.
Yes, please conclude.
So,
can you conclude? You read what you are going to conclude here. Your name is Kasturi or what?
Oh, no, sir. My name is Kirti, sir.
Kirti, yeah, please conclude also. At least tell whatever your observation about.
Yes, from the study we did, we got to know that random forest and logistic regression, we got more accuracy, sir. They both, when we make them into an ensemble model, they both complement each other.
Okay, your question is that you are using two terms. One is ensemble, another is hybrid ensemble. Okay.
Yes.
First, how ensemble based techniques is different from your hybrid? Because ensemble, always you are taking some weak classifier, you are going to take the average or combined performance. So what is different between your hybrid and ensemble? Why you have given this hybrid term?
Because the logistic regression is a linear model, sir. And the random forest is a non-linear model. As we combine these both, we gave it as an hybrid ensemble model.
Logistic regression is your linear model and random forest is non-linear.
Yes, sir.
So their decision boundary will be linear or non-linear in case of random forest?
I not get you, sir. Can you repeat it again?
The decision boundary which will generate through this random forest, it will be linear or non-linear? The classification decision bound you are asking. No?
Yes, sir.
And again, your model has error almost 11%. Does it make sense to have 11% error? That is too high, na? Classification error 11%. Almost out of 190 sample are misclassified 10 only. So
Yes, sir.
we should have further improvements.
Yes, sir. Actually, we took a data set is of only 303 records. So I think if we increase the size of the data set and also we removed the missing values, sir. I think if we replace it by some mean or something, we
Second thing you are telling logistic regression. What is your formula for logistic regression? You're telling it is linear. Is the equation of line or something different? Plan. It is sigmoid kind of function.
Sigmoid function, yes, sir. Yes, sir.
And you have considered only 13 features for your data set.
Yes, sir. We took the standard Cleveland machine learning repository, which has 13 features.
And how many samples was there?
303, sir.
Okay. Okay. What is different between feature extraction and feature selection? Because I need to find one. What is novelty of your work as a research paper? You have not compared. You have compared with other researcher, but accuracy is not high, or your performance is not that much significant difference. Okay. And what is the motivation of applying this hybrid? Does it make sense? Because you are not clear about linear and non-linear classifier. So these three was my observations. And you have not given any table name, figure name, which figure or table you are referring in PPT. Okay. Okay. This is all from my side. So these points you can take. And I will ask to Madam Fatima, Madam. Madam will ask.
Yes, sir. So my question would be regarding pre-processing. So can you talk a little bit more about pre-processing?
Ma'am, can you specify like which part of pre-processing? Like
what kind of data cleaning did you perform?
We actually removed the missing values, ma'am.
In data visualization, because you had already the features. Feature extraction was not performed by you, and that is it right?
Like I mean, in data visualization, we just we did it in order to know the number of attributes and the number of features in it.
How did you do that? What kind of data visualization techniques did you use?
Like,
how did you merge the output for a random forest and logistic regression? So what kind of rule did you use to combine the output?
we use max sorting classifier, ma'am. We use the soft sorting method.
Okay, so
yeah.
Slides for result and discussion.
Yes, ma'am.
Thank you. So can you talk about more? What about? Did you try them? Were they not performing good enough? So you tried using hybrid ensemble.
Actually, we tried combining it instead of max sorting classifier. We normally tried of combining with to make an actual hybrid model, ma'am. That is what HRFL means. But I not give that much accuracy. So we tried of combining it using the max sorting classifier, ma'am.
If you see the output of random forest, the results for random forest and your hybrid, there is not much difference.
Yes, ma'am. I think it's because of the as our data set is of only 297, like only 303 records. I think if we increase the size of the data sets, we can see the increase in the accuracy, ma'am.
Okay. That's it from my side as well.
Yeah, thank you, ma'am.
And I think there is a typo in your specificity for random forest and for VM as well.
Yes, ma'am. I'll change it. Thank you.
Yaswant and Sanke, can you ask for
Shan-
next?
Yes,
Shankil, yeah.
Can I-
next, Shikha, Dr. Shikha Agrawal. If she's not present, we can call Mr. Yashwant.
Shanki, 1 minute. Participant Anubha, Parlin, and Kirti, please, both of you, mute your volume. It's creating a lot of disturbance to other. Anubha, Parlin, if you are hearing me, please mute your volume. Yes, continue.
Next presenter, Dr. Shikha. Mr. Yashwant.
Yes, ma'am.
Yeah, you can continue your presentation now.
Yeah, okay, ma'am. Sure.
You can share your screen.
Okay.
Shanki, from your side, you can mute her, or just what is possible you can do from
Yes, sir.
disturbance.
I'll try. I'll try.
Yeah.
So is my screen visible?
Yes, please.
Yeah. So yeah, good afternoon, everyone. My topic for this research paper was prediction of heart abnormality using heart sounds, audio signals. So I'll be going through the background, literature survey, problem description, methodologies which I used, results which I got, and the conclusions that I've made. So the basic background, cardiovascular disease. This consists of disorders that are associated with heart and blood vessels, mainly due to fat deposition or cholesterol, things like that. So I mainly focused on non-invasive tests. For there are like different non-invasive tests are phonocardiogram, electrocardiogram, chest X-ray, CT scan, and all. So what is actually a phonocardiogram? It is a plot of recordings of the sounds and murmurs made by the heart. So the basic instrument that doctors generally use for recordings is a basic stethoscope. So like mainly to detect based on the sound, trained professional doctor or physician is always required. So machine learning techniques, why they play a role here is that for places where there is no immediate availability of doctors or a trained professional, so we can like create an instrument or a device that can for time being detect the defect that the heart is having, or at least alert the patient. So that's why machine learning techniques can be used. So here for analyzing any PCG signal for detecting for prediction of heart disease, mainly uh, three steps are required. One is pre-processing, second one is segmentation of the audio signal, and the third is the classification. So in pre-processing, what happens is the database or the data set that we take, so each audio signal might be recorded in different environmental conditions. So the voltage levels of the audio signals that we receive, or the ambient noise that is present in the room that we record the audio signal, that may vary. So in pre-processing, our aim is to bring all the audio signals that we have onto a same platform. That means if you like like making all the signals amplitude between -1 to 1, like I mean normalizing or and doing some noise cancellation techniques, or making the audio go through some series of filters so that a noise can be reduced and all. So after pre-processing, there is segmentation. So in segmentation, what happens is there are basically four time durations of a heart beat. So there are two fundamental heart sounds. One is S1 and one is S2, and the time between the S1 and S2, the period between the S1 and S2 is called systole, and the period between S2 and the S1 of the next cycle is called diastole. So these are the four things that we have to uh, segment the audio signal into. So the audio, each audio signal should be like partitioned into these four places, like S1, systole, S2, and diastole. So for this work, I have taken a Physionet challenge database. So in this database, they have considered 8 different independent databases that were from different universities or different hospitals. So these 8 different databases, they were available like 8 directories in this uh, like 8 directories. So I have considered 5 directories as for training purpose, and the next as a testing purpose. So the totally I have a audio sample count as 3,240 audio samples, in which 2,476 are abnormal and 764 are normal. So these were the recordings from total 1,072 patients. So these audio signals were initially, they were annotated by like professional doctors or physicians as a normal or abnormal. So yeah, so coming to the segment, like in the pre-processing step that I discussed here, so that is already done and we and the data set was given. So pre-processing is already done by the time the data is available to me here. So now we move to the segmentation which I used. So HMM is it is hidden Markov model, is a statistical model used to describe sequential data. So here what happens is the HSMM, it defines the function like each audio signal, uh, if it is trained with HMM, then the HMM will give us the output like 3 matrices. One is the transmission matrix, one is observation distribution or emission matrix, one is the initial state distribution matrix. So what is the transmission matrix? Transmission matrix, it is the like we have 4 states in our segmentation. One is S1, one is the systole, one is S2, and one is diastole. So if we are in S1, what is the probability of next state, that is systole, to come right now? Those that probability information will be given by transmission matrix. Observation matrix is identifying what is the uh, present state, that this like present state at ith moment. Now if we are currently in ith moment, so what is the present state that we are in? So that observation distribution matrix will be given. So initial state, from like we can't always say that if we are recording a audio signal it will start from S1 only. So initial state distribution gives a probability of what may be the initial state of that particular audio signal that we are using. So this is one this is actually the previous model. So one extended version of this model is the hidden semi-Markov model. Here including these 3, an additional parameter is added, that is the probability of existing in particular state I for a duration of time t. Like even the time parameter is inculcated in HMM. So that finally is a hidden semi-Markov model. So this is for segmentation. Yeah, so this is for segmentation. So after like in this paper, like what we did is in 3,240 samples that we had, 409 samples were given simultaneously with the ECG recording. So from ECG recording, it was easy to train this HMM model. So in ECG recording, the R peak and end of T peak, so those two things, they accurately show the boundaries of S1 and S2 ending. So with those things corresponding to that audio signal that this ECG signals corresponds. So based on that, based on those 409 signals, this HMM is trained in this work. So after that, after training, that is applied to the rest of the other data in the, like, apart from these 409, the other database data, it is applied, and the signals or the audio signals are classified into these four: S1, S2, systole, and diastole. So after doing that, now the classification. So classification, I took I consider like K nearest neighbor clustering algorithm. It is an effective non-parametric classifier that determines the neighbors of a point based on the distance proximity. So here only distance proximity is considered, and the K is nothing but the number of the neighbors that we are considering for that particular unclassified sample to decide which class that unclassified sample belongs to. The classification performance of KNN is disadvantageous because of the presence of outliers. So what are these outliers are, each and every data input that we take may not correspond to the may not correspond to correctly to which state, to which class the unclassified sample should go. So some parameters may have the values corresponding to the other class. So because of that outliers, this KNN algorithm can be misjudged, and the classification may vary. So
Yes, one, can you move fast on your results?
okay, sir.
Not
Yeah.
in much depth, you come on your result and your conclusion, whatever your achievements. Yeah.
Okay. So because of this, I have done Banforoni mean based fuzzy K nearest centroid neighbor. So this is a further version of KNN that I used. So methodology, this I just explained, like ECG reference based segmentation techniques are used, and based on that 409 signals, audio signals that I have, the S1 and S2 are segmented. So yeah, this is the segmentation like plot. So the like 1, 2, 3, and 4. So 4 stages I have made. So first stage is S1, second stage is S2, third stage is second stage is systole, and third stage is S2, and fourth stage is diastole. So this is for a example of normal audio heart signal. So this is an example of an abnormal heart signal. So the features that I extracted are like the mean skewness of S1. These are statistical features that I've extracted, and the classification on Bonferroni mean. So this here what happens is first thing pre-processing. So the same thing, actually whatever the audio signals that I have that I have taken. So from that, due to the imbalance in the data set, like 3000 2700 are abnormal and about 700 are normal. So due to that imbalance, there can be a most possible chance that the unclassified sample is more inclined or biased towards abnormal only all the time. So in case of KNN, that bias will be clearly meaningful or significant. So because of the centroid neighbors concept, so that thing can be far minimized. So we, from this, what we can avoid is we can avoid deleting the database. So we can include the total database, and further, like sample space of the audio signals can be increased. So this is the flowchart of the classification method. So whatever classification, how I did is 80% to 20%, 80% training, and is 20% is for testing data. So Z scores are calculated here. So what are Z scores is the score of 1 means from the mean one standard deviation to the one standard deviation away. So if the mean is something like 2, so one standard deviation away from 2 and one standard deviation below 2. So the area that is covered above 2 and below 2, the total things comes under this score of 1. So I have taken this 2.5 like threshold as 2.5, so that 95%, 95.4% of the data is considered, and the rest all are like eliminated. And after that, after this kind of pre-processing, I have implemented this classification method. So I have compared with these 5 classification techniques: support vector machine, decision tree, naive bayes, k nearest neighbor, logistic regression. I achieved a maximum accuracy of 88.4%. So these are the results, plot, and yeah. So conclusion, so for 3,240 audio signals, our data set consisting of 3,240 audio signals was considered. The HSMM for segmentation and BM, FKNC, and for classification is used. So what I found is like if the increment in simultaneous ECG data that we talked about, like 409 ECG data only was available. So with the increase in that, maybe the HMM accuracy will increase, so that it will be easy for classification, like classification gets better. So feature extraction, I have actually compared each of the features with the box plot of normal and abnormal heart sound recordings. So these feature extractions, we can try multiple ways, like taking the ratios of 2 parameters or taking the difference of 2 parameters in that way. So, and the further to this analysis, I wanted to take that to a hardware implementation on an FPGA board, so that the real-time prediction can be done. So these are the references.
Yaswant, your name is Yaswant?
Yes, yes.
Yes. So you are trying to choose your code over the FPGA. So there is any limitation you find at memory and other things, because your code will be bigger side as HMM code you are running. And second thing, why we are going for HMM only? For if it is time series data, then only.
HSMM, like I wanted to even bring the time, sir, because when heart is beating, so due to some blockage of any nerve near to any artery, so in these 4 segments, like S1 systole, S2 diastole, some or the other segment will be affected due to that one nerve. So the time so if the S1 is so quick, or if the S2 is so duration is too much, so
okay. Second question: how will fuse your code over FPGA? How much memory available with the FPGA? Because model you have to fuse there. Model you have to fuse. You will sense some data and you will predict from.
This is the like the further thing I wanted to do, sir.
And that's why I'm looking for whether it is feasible or not. Okay.
Okay.
Because you have microcontroller kind of things in which we have very limited memory, like 1 MB or something.
Yes,
whether your model which you are designing for this machine learning model, whether you have, so no one has worked with HSMM before.
They have worked, sir. Yes, I have seen. Yes.
Okay, what is your improvement?
Sir, improvement I have done in the classification, sir, like Z scores calculation, and
but
for
you have
each
not shown us results in form of some graphics. Can you show the results in form of graphics? Results after methodology results. Only 1 page of results you are keeping this code. No need to keep in code. Better prepare this table in form of table. What is the accuracy? This one. Only one PPT you have kept for this result discussion.
Yes.
Okay, those work is good, but anyway, okay. So I will hand over to next session here, Madam Fatima, Madam.
Yes, sir.
Yeah.
So I have two questions. One is regarding your features. Can you go back to the slide for your Yes. So did you explore other features as well?
Yes, ma'am. What I did is actually whatever the features that I may like think of, or whatever I saw in literature. So for all those, I compared with the box plot, ma'am. So in the box plot, we get to know the mean, the median, the standard deviation, and all. So the outliers can be like if that particular parameter is too much outliers are there. So that is not useful for classification. So if I think like that, I just remove that parameter. So in that way I compared and I have done this, taken this.
Okay. Just for discussion, do you think is more robust amplitude of taking S1 or S2 or taking mean of the deviation?
Yeah, so amplitude of S1, what I did is in like after segmentation, whatever the assigned states which I get, assigned states in the sense, like if it is partition like S1 systole, S2 diastole. So in that S1, the mean of all the S1 amplitudes that I get. So this is sample like 1,000 samples, like 1,000 heads I have sampled. So that thing, so in that S1 column, so how many ever samples are there, that average I took and I kept for that audio signal, I kept it that as amplitude of S1.
Okay. And one thing was regarding the outliers. So did you remove the outliers before splitting the data into testing and training or after?
Before, ma'am. Yes, before. Sorry, I had to like before this I have to keep this. This
Before
should be the first
step.
point. Yeah.
Okay, it's usually better if we don't touch the testing data and we keep as it is with the outliers even. But anyways, good.
Yeah.
Thank you.
Okay, thank you. So can I stop, ma'am?
Yeah. Sanjay, can we move for next one?
Sir, I called the next presenter, Dr. Shikha. She is having some medical emergency, and her co-author is also her husband is only the co-author, so she will not be able to present in this session, sir.
Okay, perfect.
So we can conclude this session, sir.
Yeah, fine, ma'am. You please continue.
Okay.
Yes.
So this is all for the track session 5, and
Hello.
I think one paper is left.
Yes, ma'am.
Jiten Shukla.
No, Sarthak Dalal.
Ma'am, just a minute. Let me check.
Jiten one paper is there.
Yeah, total 5 papers are there in each session.
Okay.
Sir, actually, I don't have this.
But that Google
Okay.
Sheet which you have given.
Yes.
Okay.
Yeah.
Okay, we can continue with this paper.
Last
Okay.
one.
Okay.
Hello, am I audible?
Yes, you are audible. You can share your screen
Yeah.
and you can start, please.
Okay, so I apologize because I was going to present on 14th, but I'm unavailable on that day. So I'm presenting in this track. That's why the confusion.
So you took the permission from the chair organization.
Yeah. I took all the permissions.
Sisodia sir or Pradeep sir?
Actually, my guide had mailed the MISP conference, and he notified me about the change.
Okay.
Sorry,
Shanti?
sir. Sorry, sir. I have some network issue I had. Sir, can you please, Mr. Sarthak, can you please repeat what's the issue?
There's no issue. I was just telling that I'm presenting today because I was unavailable on 14th.
Okay. There is a swapping. in the
Yeah,
deck?
yeah, 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 yeah,
Okay,
yeah.
okay.
Yeah.
Actually, I am having the old sheet in which only 4 presenters are there. Okay, you have mailed in the MISP forum?
Yes, yes, yes. My guide had done all the conversations.
Okay, okay. I'm noting it down and I will let the organizing chairs know about this. You can present.
Shen,
Okay,
yeah, yeah. Yes, please.
okay. Thank
Uh,
you.
Ni-
Can I
Night sir, you
share?
can present.
Yes, yes. You can
Okay.
start, please.
Okay. Is my screen visible?
Yes, continue.
Okay. Uh, so good afternoon, everyone. My name is Sarthak Dalal, and I am a student from DJ Sangvi College of Engineering in Mumbai. And the topic which I'm going to present is LexRank and Pegasus transformers for summarization of legal documents.
Your paper ID,
So
please. Paper ID.
334.
Shanki, you note down that.
Yes, sir, I have noted.
Yeah, yeah. Continue, sir. Continue.
Okay. So basically, the background is that legal documents are generally verbose. They contain a lot of text and jargons, and lawyers have to study all of these prior cases before they can fight in the court, and they have to prepare a lot. And reading all of the documents can be pretty time consuming. So summarizing and paraphrasing of such documents using machine learning has been a new topic of relevance, and so which will help the documents go through, which will help the lawyers go through the documents quicker, and that can also help the common people comprehend these documents, because these documents are so complex that if some common person wants to read them, they will not understand anything. But using a simplified document, they can understand it. So in this project, we propose a technique using the LexRank and Pegasus transformer for abstract to summarization. So this is the literature survey. We basically tested 6 to 7 different models, and for just for summarization, not for paraphrasing. So summarization has been done on legal documents as well as for any document as such. For legal documents, it has been fairly new concept. Not much work has been done in this area. So in one paper, the authors had used a data set and a supervised model using conditional random fields to build a probabilistic graphical model. So this basically has a disadvantage that that the model which is trained on a supervised model which is trained on a data set can only summarize documents of that particular case. For example, if it is trained on an Australian database, then it will only summarize documents of Australian cases. So to overcome that disadvantage, in a paper, the authors had designed an unsupervised model, which is named Case Summarizer, and it was meant to work on Australian case judgments. But we found out that using that unsupervised model, it worked fairly well on Indian cases also. So both of these techniques were extractive summarization, which basically means that you just remove few important sentences, swap the order, and make a summary out of it. You do not paraphrase it. Then we studied some domain-independent summarization techniques like summarize any documents, such as LSA, which is latent semantic analysis, and text-to-text T5 from Google. So LSA is an extractive summarization technique that will extract and prepare the summary in the order in which they appear the documents. It will not rearrange the sentences. And the T5 model flushed out very small summaries, and there were many problems like punctuations and articles in that model. So we discarded that. Basically, finally, the methodology which we implemented to get an abstractive summary. An abstractive summary is when the summary contains paraphrase sentence, like they are not same to same sentences from the original documents. You change the sentences to make it simplified. So basically, this is the flow chart. There was an input text, and you split the sentences. We took only 35% of the original document. So if there are 100 sentences in the document, 35 sentences will be used to make the summary. You can change this number according to you, obviously. And then LexRank will use the similarity matrix to find out which sentences are similar to each other and give them rankings. And then according to those rankings, a summary will be prepared. And then again, using the Pegasus transformer, we splitted all the sentences and paraphrased each sentence. And then we merged all of these paraphrased sentences to get the final summary. Basically, this is an overview of how the LexRank summarization algorithm works. In the diagram on the right, you can see that if there are 6 sentences, it will give a weight of a weight to all sentence pairs, and whichever weight is the highest, it will rank it higher and will be used for the summary. And the Pegasus transformer it was built on the success of sequential sequence learning techniques, and it is an unsupervised model. It is a pre-trained model basically, and it was built on a large corpus of 350 million web pages and 1.5 billion news articles, and it to automate the selection of important sentences using the row F1 metric, which we'll talk about ahead. So these are the results which we got, and these are the rogue scores for results. So basically, you can see 5 models in this table, and the bold one is the highest one in that particular column. So an F1 score is a mix of the recall and precision. So as you can see, the LexRank had very high precision as compared to other models, and because of that, its F1 score is higher than all the other models for both Rogue 1 and Rogue L, and even Rogue 2. So, however you want to look at the summary, it will always have a better Rogue score, the LexRank model which we implemented. This is a sample input and output. In the on the input side, there is a very small case document which we use for the presentation purpose, and for the output, as you can see, it has been reduced to like 10 sentences and not even 10 sentences, less than that, and all of the sentences are fairly easy to understand. So the conclusion is that the primary virtue of a judicial system is to pass fair and just judgment. So obviously, an AI will never replace the a judge because human instincts are necessary to determine an outcome of the case. But we can use AI to supplement and help the courts, help the judges to make the process faster. And so this is one area in which work could be expanded, so that lawyers can prepare the case faster. And apart from this, we can the future area of studies could be that if a jargon is there present in the summary, it will hyperlink it to look up what the meaning is. And also, we could have categorization of similar code cases, which would help the lawyers to find out relevant cases for their case. Basically, and these are the references. Thank you, guys. Any question?
Yes, Sarthak, can you come on result section?
Okay, so rogue score.
This is not okay. Fine. So LSA is performing better or which one? LexRank.
LexRank, yeah.
Okay. Perfect. Perfect. So far, the presentation is good. From my point, no doubt question. Maybe madam can ask question.
Okay.
Just one question. So how well this would do for other kind of documents apart from legal documents?
So we actually tested this for both the case documents and other summaries, and the result is pretty good for both of them. So yeah, I can also show you some more inputs and outputs I have on Notion of all these models, and it performs fairly good for both the types of domains.
Okay, thank you. Thank you. That's it from my side.
Thank you, ma'am. Okay, stop sharing.
Yeah.
Thank you.
Okay.
Shanky completed?
Yeah, sir.
Yes.
Okay,
All the
okay,
papers
then.
are presented.
Yes.
Again, I now request all the audience here and the session chairs and faculty members to please switch on your videos for a group photo.
And Sankey, I have one doubt. When I submitting this Google form link,
Ji.
okay, so one paper is absent, 169. So if I am not allotting marks, so it is going to not going to submit.
169.
Just that the
Okay, let me check, sir.
yeah. So
Sir,
I'm
give
unable
me-
to sub.
Give me.
Okay,
give me-
later on you can deal. I'm just giving minimum marks and I will write in the comment section which paper is absent.
Okay, sir. Okay, okay. Okay. Okay, done with the photographs. So lastly, I would like to thank all the session chairs for sparing time and making it convenient to attend it and evaluate the papers. And I also thank all the presenters. It was a wonderful presentation session, technical session, and thank you once again, all of you. Thank you. Night, sir.
Thank you, sir. Vijay sir and Binish Fatima madam, thank you very much for accepting our invitation and
Thank you, sir.
contributing
My
your
pleasure.
time. Thank you, madam. Thank you.
Thank you.
Yeah, you can now you can close, Shanki, please.
Okay, sir. Okay.
Yeah.